Right. First thing is command line interface and graphical user interface. There are two interfaces for the operating system. One can be command line. Command line means everything should be executed using a command. So Windows වලත් තියෙනවා. Windows වල command prompt. So මේක වෙනම OS එකක් විදියට එනවා. This coming as a separate. This is coming as a separate operating system. That means in full screen, you cannot see anything. You cannot see the mouse even. You can see something like this. This is the operating system. When it is loaded, the full screen is loaded with command line interface. Then you can type on it. You don't have mouse to use. Only thing that you can do is type. You can type commands like clear, and you can type ls to list the things, ls minus l to list with the details, and who am I is a Linux command. So here, so mouse is not usable here, but here since I'm inside the Windows GUI එක ඇතුලේ ඉන්න හින්දා I can use the mouse. But normally when you boot to the CLI, when you open the content with the CLI command line interface, mouse is not usable. Only you can type the commands, and you can check the connectivity PING, and so PING space www.google.com. You can check whether this site is working, right? Internet connectivity is there. So then when you have the internet connected, you can download a software, right? Or you can install a software even using command line. So all these things are possible, right? All these things are possible using command line interface, and you have to use commands. But if you need to know about the commands, you can just get the help, and you can see all the commands available. So these are the commands available, right? You can see, right, different commands, right? Those are available to use in the command prompt, right? Okay, in Windows also command prompt can be used as a command line interface. Okay, let's go back. I just want to show the interface. Graphical user interface. You have menus, graphics, icons, pictures, right? That is an interface which is having, so here command line interface, commands only. But here in graphical user interface, you have windows, menus, icons, and graphics. So you can write it within the bracket, you can write. So those are the things in GUI. And single user, single task. Single user, single task means only one user. Eka user can eka velawata. A single user can use the operating system, only do one task. Here, for an example, the terminal. So only one user can use this, and only one task, one command can be given, not many. So while downloading, you can't type another command. While accessing internet, so if you're checking internet, you have to stop that and do the next likewise, one by one task at a time. And single user multitask means only one user can use, but can do many tasks. For an example, Windows 7, Windows 10. One user can listen to music, can download the files, so same time, can copy the file same time, right? So likewise, one user can do many tasks, and multi-user single task. So multiples, this is rare, right? But so can be used in special. So for an example, let's say monitoring system, operating system in a let's say tsunami monitoring system, was operating system used in a kind of space object tracking system. That is special. A space object track කරන එකේ ඒතර ඔක්කොටම ගිහිල්ලා හැමෝටම කරන්න පුළුවන්, everyone can see what's happening. So let's say you have a COVID dashboard, OS built to display COVID dashboard. So what people can do, they can go and watch the live status of the COVID status, live statistics related to COVID-19. But that come as an operating system, not as a software. Software එකක් විදියට නෙවෙයි, OS එකක් විදියට මෙහෙම තියෙනවා තියෙනවා. That is special purpose operating system, rare. But mostly you can see multi-user multitasking. Multi-user multitasking. Let's go to the book and see. So single user operating system. Single user basically two categories. Single user, single task, single user, multitask. Multi-user operating system. Mostly servers, Linux servers, Windows servers, multi-users. Multi-users means many users can do, and actually the most appropriate word is multi-user multitasking. The multi-user operating system will be multi-user single task, multitask. Single user operating system single user single task, single user multitask. And multi-user multitask. Multi-user multitask means many users can do many tasks. Example, servers. Okay, let's say you are using there's an operating system in Google server. So many people can browse many text in Google, many things, many search, many content in Google. One can watch video, one can see email. So one can maybe access YouTube or some other Google service. So one can maybe access Google Drive. So many users can do many tasks with a single machine. Right? Many users can do many tasks with a single machine. Then we call multi-user multitasking. And multi-threading US. Multi-threading means like a single process can be divided into multiple sub-processes. We call threads. Right? That is available. You can also see the threads running in your computer. How to see the threads? Can you remember? How are the threads balan? You can go to the task manager, right? You can go to the task manager and see the sub-processors. Threads means sub-processors. Okay, so hope you can remember how to go to the task manager. Can you share your screen? Senot? Just share your screen. Just want to see whether you know that.
Okay.
Sure. Then go to the task manager and then go to the performance of the task manager. Performance sector of the task manager. Okay, still I cannot see the share screen. The reason that I'm seeing is you can see the first task. Can you see the first one? So it's like utilize, yes, desktop window manager. This one is utilizing big memory. You can just right click and try to end task. Asking to shut down, right? So it's unusual, right? That's a very big amount. So I cannot see. So now it's like, wait. Ending this process will cause Windows unstable, shut down. So that's the thing. Right, can you just go to the Explorer, Windows Explorer? Can you go to the Explorer? No. Same task manager. Right click, go to the task manager, and from that select Explorer. Right, Explorer, and right click and end process that. End process. Okay. Now go to File menu here. Go to the File menu. No, don't close it. Can you see the file menu here? Please concentrate what you're seeing in the desktop. File, new task, then type Explorer. Type Explorer there and run it. So there should be a reason for this lagging, right? So DWM is taking more. Don't close it, Puti. I didn't ask you to close it. Okay, can you just end process that? It's okay to shut down. So please log in back then. Right click. DWM, yes, go there. DWM, right click. End process. Yeah. Then click this abandoned unsaved data and shut down, yes. Okay, shut down the computer. It's okay. Rejoin after shutting down. Right, okay. Now please go to the performance. Go to the performance there. And now you can see, so, right? Please go to the performance and CPU. Please go to the CPU and there you can see the processors. Threads here. This is what I mean. Threads. Threads mean part of the processors. Threads. Multi-threading means at a given time, multiple threads. This is multi-processing, multiple processors are running. And also multi-threading, multiple threads means part of the processors. Okay, so now you can see, so part of the processors are running, and please concern about this high usage of the memory and the processor. So I'm pretty sure that something running in the background, and so you can check this with a tool like, maybe you can check with a tool like Security Task Manager. So try to install Security Task Manager, not now, later, and see whether there are any unknown programs running in your computer. It seems, because it's too slow. Cannot be slow because you have like 12 GB RAM, i3 processor of 2.4 and 4 cores in the 2 physical cores and 4 logical cores in the computer. It cannot be this much slow. Okay, let's go back. And now you know what is multi-threading operating systems. Most modern operating systems are multi-threading, multiple threads. So these threads can be run in multiple processors, right? Multi-processing, multi-threading operating, and real-time OS. So what is the difference between online and real-time? You have already written this. Okay, tell me the difference between online and real-time. Yes. Online means, so you can say the responding party, right? Online means the responding party is available, right? Responding party is available at the same time. That means I am online and you are also online. Both of us are available. So I can ask you a question and you can also give me a reply. So we can expect kind of lagging can be there. So we experienced that previously also. There can be lagging. And anyway, so we are online. But real time means, so we cannot expect such lagging in real time. And also in the real time systems, automatic sensors are sensing the environment, not people. Online is all okay. If you can do online transaction, right? Online transactions means you have to trigger that, you have to open that. So, but this real-time systems, real-time means basically no person is to trigger, but it will automatically feel the environment. So let's say your air conditioner, it's not online, it's real-time. It's cooling the environment and feeling the environment. If environment is too cool, it will stop running the compressor, right? So compressor සමහරට දැකලා ඇති air conditioner එකක් run වෙනකොට අර motor එකක් තියෙන එළිය ඒක ටිකක් තදින් compressor එක run වෙන්නේ සාමාන්‍යයෙන් cool වෙලා ඉවර වුණාට පස්සේ compressor එක run වෙන්නේ නැහැ. ඒක පොඩ්ඩකට නවතිනවා. Light එහෙම dim වෙනවා. So it will stop for a while. Then again when the temperature is like too hot, then again it start cooling. After some time again stop cooling. Refrigerator is also real time. Fridge ekat real time. It's cool into the real time temperature. Your oven is real time, right? Those are not online. We call those are real time. And real time operating systems are used in auto driving vehicles, auto brake systems, autopilot systems. Real time operating systems are used, especially for critical. The real time systems, it's actually minimum latency. It enforce minimum latency. ඒ කියන්නේ ප්‍රමාද වෙන්න බෑ. දැන් auto brake එක හෙට වැදිලා වැඩක් නැහැ. auto pilot system එක මේ වැඩ කරන්න පැයකින් වැඩ කරනවා. එහෙම වැඩක් නැහැ. auto driving should work real time, otherwise big accident. That is real time, right? And embedded operating systems are special operating systems inside within the device. At the manufacturing time, operating system is refrigerator operating systems, smart TV operating systems, mobile operating systems, right? Mobile OS, those are embedded operating systems, right? Please write embedded OS also. Time sharing for the moment, no need to write. Just write this part also, embedded operating systems, Real time, real time, did you write? Or not? If not, write both, right? So here also the real time operating system. So they have ATM machines, calculators, right? Here, so these are operating system which gives output in the real time without here observable delays, actual time without any lagging. So that is real time. ATM machines, calculators, right? That can also be there, right? ATM, calculators. Okay, please write down both. No need to write down the time share in one. Right. In the book, next thing is about services, different services of the operating system and how this managing things happens: memory management, hardware management, process management, device management, file management, network management, security management, how these things happen in the operating system. Actually, it's a resource manager, so it manages all these things. Operating system is a resource manager, it manages all these. Okay. Process management. Process management means users can do so. We saw that, right? Recently we saw that in the task manager. Task manager a user can perform tasks using a computer. So basically, one program means how many processes? If you open one program, how many processes will be there? Is it one process or more processes?
More processes?
Yes, more processes. You can just double, so open the task manager and again, right, let's see how this happen practically. Right, can you again share the screen? I think now it's not lagging, so that issue is fixed now. Yeah, can you again share? Is it still lagging? Right, okay. Right, now you can see. So can you open like a small application? Let's open Microsoft Edge example, Microsoft Edge. Let's open it. Please go to the performance, Pute. Please go to the performance section. Just close it again. Close this again. Please close this. Yeah, go to the performance. Close this app. I don't want this now. And I just want to see what's happening, right? Okay. Now please notice that how many processors are running in your computer. 208 processors with closer to 2000 threads. That means one process will have at least 10 threads, right? And utilization is 19% of the processor. Okay, now just double click in this Microsoft Edge and open this. You can see it's right. Okay. How many processors now? Please go and see how now it is 213, 214. Right. Close Edge again. Can you close Edge? Now you can see suddenly closer to 8-9 processors gone. Can you open? Can you open? Okay, let's open something like this. Yes, Google Chrome. Google Chrome. Right, you can see now 204, but when you open 216, 10 more processors open, right? So can you open Google there? Go to Google Chrome and open Google. Google. Just type Google and open it. Okay. And open a new tab. Open another new tab. And there, please open another site. Let's say Microsoft Teams. Microsoft Teams. Or Microsoft site. Okay, now just go to this and see. Now it's further increased. Right, further increased. Now this is like 217. So this is how, and you can see the utilization of the processor. It has gone up. Right, now you can close this. Close it. And you can see it's going down. Utilization will go down and processors will go down. But that is the nature of the processor. So process means program in execution. Process management means you have multiple processors running same time. And So why management? Management කියලා දෙයක් ඕන වෙන්නේ පුතේ. So that the main reason is if you have limited resources, your RAM is limited, your processor is limited, so you have limited resources, but more people need to use that, so need to be managed. 203 processors are using your processor, but you have only one processor with 2 cores and 4 logical cores, and you have limited cache memory. You have to share with all these processors. These resources need to be shared with all these processors, so you need management. Okay, then the memory, same thing. Go to the memory. Yes, here also you can see memory has like this is page pool. Page pool means, so one software, if you open a software, let's say you have a big software like this is 2 GB, 2 gig, and this 2 gig software is divided into manageable pages, small manageable pages. These pages will be then taken from the virtual memory to this physical memory. Otherwise, if you load all 2 gig, so your memory will be filled. So you are loading only a limited amount. And non-page pool means some are not page, some are directly load from the storage, hard disk, without paging. You just load directly from the hard disk, that is non-page. So memory also had a speed, and it has a capacity, available amount, right? And cached means, so whatever frequently used is saved. That cached location is also there. Okay, so let's go back and write down these, and what is memory management, what is process management. So now we saw that. Okay, process management is basically, so what is process? You should know what is process, right? Under process management, you should know what is a process. Okay. Tasks of operating systems. Tasks of operating systems. Number 1, it's a resource manager. Number 2, it is an intermediary. Don't write. Between user and the computer hardware, which provide a CLI or GUI interface to interact with. Also, it hides the internal complexity of hardware. It hides the internal complexity of hardware. We saw this. GUI CLI interface already we saw. Resource managing part also we saw. What are the resources managed by the processor? Yes, tell me the list. List of things managed by the processor. You said that you read the lesson, right? What are the resources managed by the, so I'm listing one, process management. Anything else? Yes. Hello, can you hear me?
Yes, sir.
So what are the other management tasks?
File management.
File management. Anything else?
Security management.
Security. Memory management. Network management. User management. Hardware management. Application software. Management. Application software management. These are the management tasks done by the operating system. In the book also you have some list of tasks mentioned here. Memory, device means hardware management, right? File management, security, network management. These are the things, right? Okay. So This we learned process management, file management, security management, memory management. Yes, this we learned. And why we need resource management? So why we need resource manager? Because limited resources and many components are using these resources simultaneously. එකවර ගොඩක් අය use කරන නිසා තමයි මේක ඕන. So many resources, so limited resources, but many components are using these resources simultaneously. එකවර ගොඩක් අය internet facility එකකම Zoom is also using internet, Google is also using internet, maybe YouTube is also using, your team is also using some notification, Windows update is also using internet. So when there are many components which to use simultaneously, එකවර ගොඩක් අයට use කරන්න ඕන වෙද්දී, but if you have limited resources, you need to manage. Okay. Now you can write down it for this. So what is the last one? It hides the internal complexity of hardware. What is that? Right. I already said that the saving process is complex. This is an example. Saving process to the computer is complex. For an example, if you go here and let's try to save. Let's understand like something like this. Let's go to animal graphs. Okay, so you see here how hard disk is work. So when you save a file, the file details or the binary will be sent to the hard disk. Details will be sent to the hard disk, and hard disk has these actuator and platters, rotating platters. These actuators are moving the read-write heads from back and forth. It's moving forward and backward, and this spindle is rotating the disks. And when there's a magnet, this magnet will send the magnetizing part that can be south-north or north-south. When it rotating, the permanent magnet will issue the magnetism. That magnetism will go through this, and using the read-write head, it write this magnetism to the platters. The platters වලට මේ magnetism එක චුම්බකත්වය තමයි write කරන්නේ. ඒ කියන්නේ මේකේ තියෙන platters කැරකි තියෙද්දි මෙතනට එන signal එක ගිහිල්ලා මේක හරහා ගිහිල්ලා then මේක spindle එක කැරකි තියෙද්දි මේ north south particles මේ විදිහට මේ head එක magnetize කරනවා එයාගේ තියෙන චුම්බකත්වය හරහා මේ පල්ලෑ තියෙන platter එක. So this is 1 representing, this is representing 0. Ones and zeros are written to the hard disk this way, right? So this is a complex process. This is a complex process. When there's a complex process, your operating system will hide that. You cannot see the complex process because your operating system will automatically save your file. When you save the file, you cannot see anything. File is saved. You can see file is saved, that's all. So it hides the internal complexity of hardware. Okay, now you can write this today. Task of the operating systems. Please write this part. And I'll ask one by one. Is be ready to explain.